So chapter 1, section 1.1, we're going to be talking about angles and degree measures. Angles is defined as the union of two rays with a common endpoint. So this makes sense, right? An angle is going to be two, right? Two rays. Now this is just a straight line. So when I connect another angle on it or another ray on it, I get an angle. The vertex, right? We have a vertex and it's usually the center. Angles is often thought of as being formed by rotating one ray away from the fixed ray as indicated. So here we go. We have a terminal, which is the one that is moving away from the initial side. So the fixed ray is the initial side and the rotated ray is the terminal side. So if you need to, I would encourage you to make a little note on this here. Sometimes it will help you to understand what's going on in the diagram. An angle whose vertex is the center of the circle, as shown here. The figure shows a central angle. So we have a central angle, we have an arc of the circle through the terminal side that moves interceptible arc. So here we go. An angle in standard position is located in a rectangular coordinate system. So a rectangular coordinate system is our X and Y graph, right? Okay, so the system with the vertex at the origin, so here's our origin. Our origin is the order pair of 0, 0, and the initial side of the positive x-axis shown. So when we're talking about a rectangular coordinate system, remember last week we talked about that in this particular section here, it's called quadrant 1, we know that our x is positive and our y is positive. And this is what it's telling us about the initial side is in the positive of the x. Okay, the degree measure of an angle is the number of degrees in the interceptible arc of a circle centered at the vertex. The degree measure is positive if the rotation is counterclockwise and negative if its rotation is clockwise. So I would make a note on that. Sometimes it helps. Here is our degree measure of angles. This here, I would screenshot it. I would write it down, make a flashcard, whatever you need to do, and have these angles. Eventually, we're going to add radians in. We're going to add a lot of good stuff to it. So this is building the unit circle. You need to know this. These are names of the angles. We have an acute angle. We have the straight angle, which that makes sense, right? It's 180 degrees. The acute angle is 20 degrees. And then we have a quadrilateral angle, and it goes all the way around to the y-axis here, which gives us a degree of 270. An obtuse angle is 120. So if we was to think about it, this should be like the 90-degree angle right here, right? And if you go over just a little bit more, you get the obtuse. And then, of course, the right triangle, or I call it right triangle, is because I always think of a right triangle when I think of 90 degrees. But whenever we have the X and Y making an L shape, we have the 90-degree angle. Coterminal angles. So we have our initial side, and it's going around. It went around to the 270. And then we have our terminal that went a negative direction, right, of 90 degrees. We have a coterminal. Angles of the alpha and beta are coterminal if and only if there is an integer k such that, and we have this formula. So write this formula down, guys. We will be using it. So here's an example. Find two positive and two negative angles that are coterminal with a negative 50 degrees. So it says there are infinitely many possible answers choose positive integers, 1 and 2. And the negative integers, -1 and -2 for K. So I'm going to pick some points. I'm going to pick when K is 1, K is 2, K is -1, and K is -2. We're going to plug it in, right, in each formula. And
slow down just a hair so I can write some of this stuff down.
oh, yeah, sure.
Thank you.
You're welcome. Here, let me go back right quick. Here's the formula that we're using right here. And we said that we're going to let K equal the 1, 2, and -1 and -2. They gave us the -50 right here, degrees. So we plug it in and it gives us the coterminal to that, -50 degrees. Yeah, I talk a little fast, so I apologize. Thank you.
No, thank you. I appreciate that.
And guys, I'm going to upload this that we're doing tonight in Canvas. I'm also going to upload this PowerPoint here, that the one that's not going to be written on, in Canvas for y'all tonight. So you'll have access to everything I show you.
Cool. So I can go back and take notes when I'm done. Okay, cool. Thank you.
You're welcome. So are we ready to move on?
Yes, definitely. Thank you.
Okay, so minutes and seconds. Each degree is divided into 60 equal parts called minutes, and each minute is divided into 60 equal parts called seconds. A minute is 1/60th here of a degree, and then a second is 1/60th of a minute. Or we can say 1/3600th of a degree. And we're going to work out some here in just a little bit of these examples once I get through the PowerPoint. I'm just kind of introducing the section right quick. All right, so it said, let's convert this 44 degrees, 12 minutes, and 30 seconds into degrees, all into degrees. So what we know is we have 12 minutes. And what I know about 12 minutes, and guys, make you a formula sheet for sure. You need to write this down right here, what I'm highlighting. You need to know it. It will make it so much easier for you. Put it separate from your notes. Okay, so I have 12 minutes, and I'm going to set up my conversion. I know that I'm wanting to turn it into degrees as my end unit, right? So I know that if I take my 12 minutes times, and for the visual learners, you can put a 1 underneath the 12 minutes. So you see that you have this fraction times this fraction. Make sure that you set it up where your minutes reduce with minutes. And we're going to use this one here because that's what's compatible with the minutes. It converts back and forth. So I have 12 divided by 60, and it's all going to be multiplied by 1, which reduces to 1260. Or excuse me, it simplifies to 1260, but it didn't reduce it down. We need to convert this to a decimal, but they said, let's wait and do it here, which makes it a lot easier because if you do it before then, the decimal could be so yucky. Now we're going to do the 30 seconds. We're going to take what we know and we're going to plug it in again. And if you need to, put a 1 underneath the 30, mark out the seconds. If they reduce with each other, then we set it up right. Left me with 30 over 3,600 degrees. We're going to plug it in right here. How do I know this? Okay, so this is what was given to us. And if you notice, the 44 is already in degrees. So if I take that 44 degrees and add it to my degrees of my minutes after they're converted, added to my degrees of the seconds after it's converted, then it's going to equal something in degrees. Does that make sense? So if we don't turn this into decimal and leave it in fraction form, it's going to be a lot easier. Also, be careful about the rounding. It may be specific on how to round. In this case here is the 10,000ths that it rounded to. You see this squiggly line here? This means approximately. It's because it's not equal to. The only way that you're going to see the equal sign is if it's exact. And since we're rounding and working with decimals, it's not going to be exact. Okay? So any questions on that? I think this, to me, I like doing this part. I think this is fun. I like doing these. All right. So here we go. This is in degrees and we want to convert it to minutes and seconds. Here we go right here. Right? So what do I know? I know in front of the decimal, I have the 44. That's automatically degrees. So that part's done. Okay. So I can come and put it right here in my end answer. What I need to work on.
The chat needed to go back.
Do what?
In the chat said someone needed to go back.
Here we go. Yeah, I got to figure out how to put the chat over here without it being recorded. If I put it on this other monitor, it gets recorded.
I can, if you can't see, I can just tell you like when something pops up.
Oh, that would be great.
Yeah,
Thank you.
that. That's no problem.
Just let me know when you're ready for me to go.
They said they need you to go. Could we go back? I just need the last line, it says.
Oh, okay, okay. Okay, so moving. So hopefully it's good. And I'm going to upload this, I promise. So on this, this next one, we're talking about in degrees. We're converting it to degrees, minutes, and seconds. Again, the number in front of the decimal is already in degrees. So that took care of that work. Here is something you need to highlight and know. 1 degree equals 60 minutes, which I said that on the other slide. Sometimes it helps just to remind you. And what I'm going to do is I'm going to take the decimal here and I'm going to convert it to minutes by setting it up using this conversion. My degrees reduced. So make sure and set it up correctly, okay? And how do I know? I'm going to put a 1 underneath this decimal because I'm visual. I'm going to make sure the degree reduces with the degree. See, it reduced. And now I got 0.235 times 60, all divided by 1, and it's left in minutes. Now look at what's in front of the decimal, and that is my minutes right here. Almost done. So now what do I need to do to find seconds? I'm going to take this decimal here. Oops, I meant to change that. Let's see if it'll let me. I'm going to take this decimal here, and I'm going to convert it to seconds using what I know. I know 1 minute equals 60 seconds. So I'm going to take that 0.1 minutes. I put a 1 under it. I'm going to make sure that when I set up my conversion that the minutes reduce and leaves me 0.1 times 60, which gives me 6 seconds. And that gives me my final answer. So now I converted this to degrees, minutes, seconds. And that's all of 1.1 as far as the PowerPoints go. So I'm going to pull up some of the some examples to work out with you. Hopefully they will be helpful.
I think they're all good now. It says good, thank you.
Awesome. All right, thank you. Now, okay, let's go to our examples. So this is the, can y'all see my notes here?
Yes.
Yes.
Awesome. Okay, so I pulled some stuff because I thought this is really good for you to focus on. And if you want to separate it from the PowerPoint and put it with the notes that you work out, or if you just wanted to print a certain page, you can. So I put these on here, put a little bit of information. I felt that it was really helpful. And look, I put the unit circle. I will probably give it to you more than once this semester. The unit circle is going to be a lifesaver on a lot of things in this course. So you definitely need it and need to learn it as much as possible. Okay.
Is that available to print?
Yes, all this will be available to print.
Cool.
And And I'll probably do, well, I know I will. I'm gonna do the unit circle separate. You're gonna have unit circle, and then you're gonna have it in this notes. So you'll have more than one way to get to the unit circle. All right, so let's talk about the first question here. It says an angle of theta is in blank if its vertex is at the origin of a rectangular coordinate system and its initial side coincides with the positive x-axis. Can anybody tell me just the best guess? Okay, it's going to be standard form. Whoops, let me get back to my pencil.
Sorry, it just takes me a second to reread the question and try to visualize it.
Oh, okay. So it's standard position. Now you'll just see this in the homework. I'm not going to be asking these type of questions on the exams. On the exams, I want to see the math work, and I want to see that you can solve it and you can determine a specific point. This here is just to make sure that it helps you with the actually visualizing it. So on the homework, when you see this part, you may want to have your notes so that way you can reassure yourself on what it is, because I'm a visual, so it helps me. The more that I correct myself while I'm doing it instead of afterwards, the better I am. I'm not saying that you all are that way, but
That's
sometimes
how I
it's
am
helpful.
too. That's how I am as well.
Yeah, if you don't correct me, I'll go all day thinking that's correct. So I'm better to know it as I'm going. An angle with the measures between 90 degrees and 180 degrees. Do y'all remember from what ago when I was showing you the degrees, which one this one is?
Obtuse.
Good, yes, obtuse. Because I
Uh,
said, yeah, because 120 degrees was obtuse. Okay, so a blank is 1/6 of a degree.
Minute.
Awesome. Okay, so now let's do this next one. So what I want to do on this one here says, find the degree measures of the next two position and the previous two negative angles that are co-terminal with the angle 85 degrees. So we used, remember that formula we had earlier? It was, let's see, and I'm doing this from memory. I believe it was little m plus the 360 degrees. All right, so now, oh yeah, I forgot the K. And then I said, okay, what we need to do is we got to say, let's let K equal 1, let's let K equal 2, K equal 3. Oh, sorry, not 3. I got carried away there. I just kept on counting. K equal -1 and K equal -2. And they already gave us what we need to go right here. So what I'm going to do is I'm going to make me a little table. When K is 1, I'm going to plug in. Oops. Does anybody got an answer for me on this one? And do y'all have a calculator? I can show you.
445.
Yes, yes, very good. I can show you on the calculator how to plug these things in. You want to make sure, since we're talking about degrees, that your calculator is in the degree setting. When we're talking about radians, you want to make sure it's in a radian setting. So, and I buy a little $15 calculator and to use. So I can go over that after we finish this section if any of you would like to see that. So now we're going to plug in when K is 2. Anybody tell me what you get on that one?
805.
Yes. Very good. K equals -1.
-275.
That's what I got so far. We're good. Yay. And the last one, when K equals -2.
-635.
Got her a little faster this time. Very good. Yes, that's what I got. Awesome. So it's not too bad, right? Therefore, we have all these sites. All these are coterminals to my 85 degrees. So if I put it on there, they'll be the coterminal of the 85 degrees when K is at all these points. Okay. So let's look at this one. Oh, this was an example. I actually just worked it out when I said negative 77 degrees. So when we let the angle be negative 77 degrees, we're going to find those coterminals by plugging in K. So I actually worked that one out as an example for you to have. So this next question, we want to determine whether the angles in the given pair are coterminal to 155 degrees and 1,235 degrees. So we want to know yes or no if it is, and we'll have to solve it. So if I did that, we're going to take this formula that we was just working on. And I want to leave K out. And since it's multiplication is commutative, the order don't matter. So for example, 2 times 3 is, anybody?
6.
3 times 2 is?
6.
So multiplication is commutative. So the K can go in front of the 360 or behind it. It doesn't matter, okay? So you'll see me flip-flop it, not on purpose, just a habit. So now I want to solve for K because we want to know if these two degrees here are coterminal. Okay, so in order to do that, I'm going to plug them in. So I'm going to say 1235 degrees. I'm going to set it equal to the 155 degrees plus K 360 degrees. And I'm going to solve for K. When I solve for K, that means I need to get it by itself. In order to do that, I need this 155 degrees to go to 0. And since it's positive, I'm going to subtract it. And what I do to one side, we do to the other. That went away. Now I have K 360 degrees is equal to 1,080. So next, I need to solve for K. And since K has been multiplied, also called the K's coefficient is 360 degrees, I need to divide by it. If I divide by that coefficient, it becomes 1. And 1 times K is what we're wanting. So now I'm going to come up here, and it gives me K is equal to 3. So since the equation has an interval or integral solution, the given angles are coterminal. Yay. All right. So let's do the next one. Are y'all okay so far?
So far, so good.
Yep.
Okay, so I want to do this next one. It says, name the quadrant in which the angle of 668 degrees falls in. So when we draw this unit circle or draw the Cartesian coordinates and we go all the way around, can anybody tell me what's the degrees when we go all the way? We start at 0, but we end at what?
360.
Very good. So that means I'm going to take 668 degrees minus 360 degrees. And it tells me that the degrees is 308. And when we go to the unit circle, where does 308 end? Well, this particular point is 270 degrees. And you said this is 360. Whoops. That means 308 falls right here. And 668 meant that it went around and came back around and landed right here. So it's in quadrant 4. Okay. And I got someone in chat. Oh, very good. Thank you. Yeah, you gave me the answer. Awesome. Okay. So the next one says, find the angle of at least positive measures that is coterminal to with A equal negative 82 degrees. All right, this one's going to be a little bit more work. So we want to find at least a positive measure where it would be. So remember the coterminal angles differ by a multiple of 360 degrees because that's the complete circle. Well, what can I do? I can take this 82 degrees and add it to the 360, and it gives me 278 degrees. So that gives me a particular point. So now I can plug in and solve like we did before. And we have $278. This one is going to be a thinking one. Okay. Okay. So 278, I take it. So we know that a negative 82 plus 360 gave me 278. I take this 278 and add the 360. That gives us another degree, and we add it. If y'all get one of these problems in your homework and it's kind of a challenge and you're having trouble because there's multiple different types of answers we can get here, let me know. But we're looking for the positive measure, so that's why we added. If we subtract, we would have came out with a negative. So if like I said, if you get this one on your assignment or whatever, just holler at me and I will help you through it. This one's just a little bit more in depth. Like I said, there's multiple answers here that we can get on this one.
Wouldn't that be 638?
Oh, very good. Thank you. Yes, because 1 plus 2 plus 3. Very good. Yay. All right. So 61. 61 says match the following degree measure with its angle. So when you're on my labs looking at it, you may have to click the view it in, or make it bigger so you can see it a little bit better, because they're not going to be exact. It's not going to give you like lines telling you this is a particular point. So you're going to have to get as accurate as possible. So what I'm going to do is I'm going to take my negative 45. I'm going to add it to the 360 because I'm trying to figure out where it's at on here. Some of you are going to already know. It's going to give me 315 degrees. So now I'm going to go look for the one that falls in quadrant 4. This one didn't, so I'm going to mark it out. This one didn't, and this one didn't. It worked out. Now, sometimes it's going to give you 2 quadrant 4s, and then you're going to have to figure out which one's closer to 315. But this is the best choice. All right, now let's convert. We're going to convert this here to 4 decimal places. So we want to convert it all to degrees. So we just did one like this, similar. This here stays the same, right? Because it's already in degrees. So it did some of the work for us. So I know when I do my answer, I'm going to go ahead and have 32 ready. Now I just got to find the rest of it, right? So what do we know about minutes to degrees? Anybody?
1 minute equals, shoot, I just had it. Dang it. It just slipped my mind. Sorry.
No, it's okay. It's 1 degree to 60 minutes.
That's right. That's right. Sorry, I had it backwards.
No, that's okay. So this is, this is good practice. So I'm going to take this 4 minutes. I like to put 1 under it. You do not have to. I'm going to multiply it to this conversion that I know. And since I want minutes to reduce, I need it in the bottom. And I want degree as my end answer. So you definitely want it on top. So now when I go to reduce, my minute reduce. So I set it up right. Left me with 4 times 1. 1 times 60, and that's degrees. And I am going to leave it in fraction form just so that you don't want to mess up by 1/10 of a point because it can throw you off like crazy. So now let's solve the seconds. So I know on the seconds part, I know that there is 1 degree is equal to 3,600 seconds. So let's solve for it. I got 25 seconds I'm gonna put a 1 under it, times it to this conversion I know. And since we want degree, we want on top, and we want the seconds to reduce. So now let's make sure that we can mark out our seconds, and it's set up right. So 25 times 1 all over 3,600 degrees. So now what I can do, and I'm going to erase this over here. I am going to set up my next formula. Draw a line right here. So my next formula is, take my watch off, it's scratching my pad, my track pad. Okay, so I got 32 plus, and it's degrees, plus the 4 degrees over 60, or 4/60ths of a degree, plus 25 3,600ths of a degree. And then anybody want to give me a number on this? Round to the 4th decimal. I'm gonna cheat. I already know the whole number. Anybody?
Is it 385 or 3,600? Is that what ends up being the decimal? Or I mean the fraction, sorry.
What'd you say you got for the decimal?
I converted the 4/60ths over to 3,600, so you could add them together.
Oh, okay.
And then I
Okay.
got it was
So you did the 460 plus the,
385 over 3,600 is what I got. Was for the fraction anyway. I didn't do the rest of it yet.
Is it 32.0136?
okay, I got 32. Let me double check because I got something. I got 32.736. So let me check. We're just off by a difference there. So we got the 32 plus the 4 over 60, correct? Plus the 25 over 3,600. And this is what I keep getting right here.
Okay. So to answer the last question that was asked, because I did the same thing, converting the 4/60ths to 3,600 will not come up with the same answer.
Right, because it can knock you off by this, in this case, probably 100. Well, in this case, it looks like 100ths, but it's probably a tenth or a thousandth of a point to cause the hundredths to be off.
I had the same issue.
And okay, so, and guys, and I'm glad that we came across this because in my labs, there's more than one way to answer this, right? If you reduced it early, added up, the decimals come out a little bit different. In my labs, though, they don't want you to reduce these until the end. And if you do, then your answer is going to be off. Does that make sense?
Yeah, that does make sense.
So you'll be in my labs going, I'm doing it right, but my answer is wrong every time by thousandths or hundredths of a point. And all it is they don't reduce until the end, and the software only knows what they tell them the correct answer is. So I would wait until the complete end to reduce, and make sure on the rounding on the 4 decimal places. Does anybody need me to go over how to round?
I was just having trouble adding them together. Like if you're not gonna convert, 4/60ths to 3,600, then how would you go about adding them together?
Well, so here's how I did it, and I was trying to see the numbers in my head, how you were seeing it. So if I was to go ahead and convert this all to the 3,600, it would have been 32 times that 3,600, right? Plus the 4 times 60, because 4 times 60 gives me 3,600, plus the 25, and it all be over 3,600. And this is how I would have done it if I was going to convert the fractions to where they all had the same common denominator. And then I would have said, okay, then 32 times 3,600 gave me what, 115,200 plus 4 times 60, which is 3,600, plus the 25, and then we can add those together. And that gives me 115585 divided by 3,600. And then I would say, okay, let's divide that 3,600. And this gives us 32.106944444. Ain't that crazy how that works? I mean, look at the difference. I typed it in just like this, and the calculator gave me this as an answer, and in my lab said it was correct. So when I converted all these, and let me double check something, 4 times 60. Oh, this is what, I have a typo here. Y'all see it? Anybody call me on it? What is 4 times 60?
36, it's 2,400.
2,400.
240.
Yeah,
There's 240, sorry, I added a zero.
240.
but 60 times 60 gave me the 360, right? Right here. Gave me
Yes.
the common denominator, and that's why I chose 60 on top. But it, for whatever crazy reason, it threw it off by just a little bit. Oh, and right here. No, that ain't a crazy reason. It's because I just literally, yeah, y'all said the right answer. 4 times 60. This should have been 240. You're right. I don't know who said the correct answer. That changed everything. So something that small can mess you up so easily. I usually double check my answer quite often. And now we're going to be on the right answer. Yeah, so I did my boo-boo right there. It helps. I mean, it's human. We do make mistakes sometimes. And then we round. Very good.
Yeah, that's the answer I got too. Cool, that's right.
Yeah, yeah. So, I mean, do you see my little mistake, how costly it was? So when we decide to go ahead and round, and I mean, mathematically, my mind automatically went least common denominator. But then it was easily to make a mistake. Okay, then I said, okay, well, let's use the calculator and just type it all in at once and let the calculator. Yeah, that kind of takes away from me doing the math. I could do the math in my head. Sometimes we get the numbers so big, we need the calculator just to double check. That something so small can throw you off. And it's normal. So don't feel bad if you make a mistake, okay? And holler at me if you have any questions or need any help at all. So let me look. We are almost done. I would like to work a couple more of these problems. And it looks like 3 more. And then that will finish up section 1.1, and I'm going to give y'all a break. Are y'all still writing this part down, or?
I'm done, but let me check the chat real fast. Yeah, I think everybody's done writing it down.
Okay, so I'm going to erase what's here so I can work. We can do the 75 one. All right, so let's do 75. So what do we have? We have a negative 18.534 degrees, and we're going to convert this to minutes and seconds. So I know that we have the first digits in negative 18 degrees. So some of the work's already done right there. So if I wanted to, I can come over here and do my answer. I just got to be careful since I am visual that I don't want to do my math work too close to where I'm going to put my answer because I'll mess it up. So I'm going to come over here just a little bit, and I'm going to take the decimal. It is already in degrees. I'm going to put the notation or the abbreviation instead of the actual degree sign. You could do either or. And I'm going to make a statement over here. What I do know, I know for every 1 degree, that equals 60 minutes. Since I know that, now I can go ahead and set up my conversion. And I'm going to reduce my degrees. And now let's solve. So now I got 0.534 times 60. And double check, everybody. I got 32.04 minutes. Make sure y'all agree with me.
That looks right to me so far.
All right, good deal. So now I know what my minutes is, right? My minutes is the numbers in front of the decimal then. All right. So I'm going to come over here and I'm going to put my, oops, get my pen to work. 32 minutes. All right. And thank you guys in chat too. Very good. So now I'm going to take the 0.4 minutes, right? And let's convert that to seconds. Well, what do I know about minutes and seconds? We know that there for every 1 minute is 60 seconds. So I'm going to set this up and let's solve. I need the minutes to reduce and I need seconds on top. So it leaves me a 0.4 times 60 seconds. And I get 2.4 seconds. I get something like that. Did y'all get 2.4?
That's what mine came up saying.
Okay, so,
Look,
huh? Very good, okay. So we're gonna go with the number in front of the decimal. And now we have our seconds. And that is our answer. Not too bad, right?
So there's no, on the seconds, there's no rounding it. Like if it was 2.7, you wouldn't go to 3.
I would,
Okay.
however, I haven't seen anything that that waivers that. Because you can't just drop the digits. However, if you come across it, send me a picture or email or tell us in class that you came across it in labs. But as a mathematician, I would round it because I wouldn't just drop it off.
I got a question.
Yes,
0.4 multiplied 60 is 2.4 or 24?
2.4. My decimal is not very big. It's 2.4.
Really?
So make sure and put a decimal in front of your 4. 0.4 times that. Or did I, hang on. No, guys, she called it. Very good,
It's supposed
kudos to
be
you.
0.04, yes.
It's 0 point. Looky there. Kudos to you, very
I
good.
was just about to ask about that.
I took
Yay, okay, very good. Yes, I left the 0 out on my paper, but I did not on my calculator. Very good, kudos. All right, I love this, y'all are talking.
So it still equals 2.4 even with the 0. So, okay, so you just missed that there. Okay,
Yeah, I messed up on my paper, my writing, but I didn't on my calculator.
okay. I was just a little confused.
Yeah, and you see how easy that.
That's why I
What?
didn't, it's because I got the right answer too, and I didn't see that you didn't put the 0 on the screen. I did the math right, but I didn't see that you wrote it down wrong.
Huh. So we got 2 more problems. This next one is not bad at all. I think y'all are gonna like it. This next one says perform the calculation. Okay, so what do I have? I have 55 degrees, 11 minutes, 62 degrees, and 46 minutes. We know in mathematics that we only add up our common denominator, or not denominator, common terms, right? So we know degrees can add with degrees and minutes can add with minutes. So I'm going to take my 55 degrees and then I'm going to add it to the 62 degrees and it's going to give me 117 degrees. I'm going to take my 11 minutes and add it to my 46 minutes, and I'm going to add it, and it's going to give me 57 minutes. And now I got my new, so y'all double check, make sure you agree with me.
I think we did this one right.
Yay!
I agree.
Awesome. All
So if
right.
this was, I have a question. So if this was like a negative, would you get a negative degree with this or no? Like if it was
So
55 minus the 62, would you get a negative in there or no?
yeah, you can get a negative degrees.
And minutes?
Yes. And here's
Okay.
and that's a good question. And here's another thing. If that would have been 62 minutes, we'd have to work with the degrees and minutes and do some work on it because we can't go over 60 minutes, right?
Okay.
All right. So the last one for this section, we're going to find the degree measure of the angle alpha in this figure. All right. So I don't know if you can see it. This here, I'm going to write it down, is 83 degrees and 43 minutes. And this one here is 30 degrees and 46 minutes. And now we want to find alpha. We want to find this one. And in a triangle, all the sides have to add up to equal. Can anybody tell me what all the sides of a triangle has to add up to?
180?
180.
Yes, yes, awesome. So I'm gonna take my alpha, oops, I got carried away, plus sign, plus the 83 degrees, 43 minutes, plus the 30 degrees, 46 minutes, whoops, minutes, not degrees. And it's gonna equal 180 degrees. So now what we're going to do is we're going to put together our like terms, right? So we're going to say the 83 plus the 30 degrees, the 43 plus the 46. And I got alpha. And I'm going to do a little parentheses, okay? Just so y'all see, and I didn't skip the step. All right. So when I do the math, double check me, I get the output. A little early on that one. Plus, so 83 plus 30 gives me what? 113 degrees. And then
16.
Huh? Did you get something different?
116 degrees.
I got 113.
Okay. I did it in my head, so.
Oh, I'm sorry. I was adding the 43 to it. Sorry.
No, that's okay. I was doing it in my head, and I mean, it's easy to get the numbers off. Okay, so we got 43 plus 46, so I got 89. So here we go. This is where I was talking about that you're not supposed to have over 60. So before I do this next part here, what I want to do is, very good, 89, awesome. So what I want to do is get this equal to the alpha. And in order to do that, I need to subtract this from both sides so I can get it by itself. And then I'm going to come up here. So I got 180 degrees minus that 113. But before I start that, we need to work with this 180. We know that 180 degrees is 179 degrees, 60 minutes. Whoops. And why am I doing this? Because we have minutes involved here. Okay. So now minus the 113 degrees, 89 minutes. Sign minutes. All right. So now I'm going to say 179 degrees minus that 113 degrees. And we're going to say the 60 minutes minus the 89 minutes. Okay. So when I do that, what do I get? I get 179 minus 113 off the top of my head is 60 degrees, 66 degrees. This here is going to give me a negative minutes. Y'all agree? A negative 29 minutes. All right, so we have to work with this. We have to get this cleaned up just a little bit. So I know if I subtract 1 degree from the 66, I still have the negative 29 degrees. It gives me my 65 degrees because I subtracted it. However, I need to add on the 60 minutes right here to, and I did my parentheses just a little bit too early. Right here. Because I need a positive minutes. I don't need the negative. So when I take 29 and 60, let's see, it gives me what, 31 minutes? Right? And that is my answer. So the reason I subtracted 1 is because I had to compensate the 60 minutes that I added on. You can't just throw the 60 minutes in without acknowledging it from the degrees. That makes sense, or vice versa. So in order for me to fix this minute that was in a negative format, I had to add the 60 minutes, but I had to pull it from somewhere, and I pulled it from my degrees.
Can I ask a question about how I did it and see if it just happened to work this time and won't always, or if it will, something that will generally work?
Can you show me a picture of it? Because it might be easier for me to see it.
Well, all I did on the 113.89, so the 113 degrees, 89.
Hey, you cut out. Say it one more time. I'm sorry.
The 113 degrees and 89 minutes,
Yeah.
I took 60 of those minutes and subtracted them out and just added another degree. So I had 114 degrees.
Yeah, that'll
then
work. Yeah.
29 minutes.
Yeah, that'll work.
Okay.
Yeah, there's more than one way to do this. But just be careful when you pick the way you like, because you're going to be less likely to make mistakes.
Right. I just wanted to ask because I know in some things it works for certain numbers, but doesn't always work.
Right. You're right about that. Okay.
I just had a question. Is the worldly application for this type of math, is it nautical in nature?
Say that one more time.
The worldly application for this type of math, is it nautical in nature?
It depends on are you asking, is it something that people actually use?
Yeah, like for like.
Yeah, it
working
depends
a
on your
submarine,
major.
or if you, like,
Yeah,
you're out in the ocean or
this
whatever.
this is great for engineers.
Engineers. Okay, I was just wondering exactly what it would be used for.
Now, there's other fields that use it too. I mean, there's some science fields that use it. Off the top of my head, though, engineers, I work with some people in the science department that use a lot of this math on some of their research and stuff. So yeah, and if you was to be a person that likes to go sailing a lot, this would be great.
Yeah, that's what I was wondering. It kind of reminded me of some of the stuff like when you go sailing, like you have to know some of these degrees and like the minutes and stuff like together, and it's weird seeing them together.
Yeah, it's pretty neat. I like it. Well, I'm going to stop the recording now, guys. Let me stop it. And let's see, let's stop recording.